Hello all, this is 10.6, which is dealing with circles and arcs, and we're just going to jump on in. First thing you need to know is what a circle is, and a circle is the set of all points that is equidistant from the center. Keep in mind as you're taking notes on this that you can pause me if you need to. The set of all points that's equidistant from the center. So if you look at this circle off to the side here, the distance from X to the circle, any one of these, is the same for all of them. That's getting us all of these points all the way around the circle. So a circle is just the set of points that are always the same distance away from the center of the circle. Okay? You always name a circle by its center. So again, if you're looking at the circle over there, we would call it circle X, which you may write like this, or you can just write the word circle X. But if you're going to do it in symbol form, you always do a circle with a little point in the middle to show the center. We would say in this picture here that AC is a diameter, and a diameter is going to go all the way across the circle through the center of the circle. So the full distance across AC here, that is a diameter. Then we have XB, and XB, if you look, never mind that it hangs over a little bit, but XB we would say is a radius. So a radius is going to be half of a diameter. Diameter goes all the way across, radius goes halfway across the circle. Both of those have to go through the center. So both of them use X as a point of reference. Okay. And then last thing on just terminology here, angle AXB. So if you look at AXB here, let me just highlight this. AXB, that's this angle. It says angle AXB is a what? That is called a central angle. We've talked about that a little bit already. So that's a central angle. So those are just some of the terms you're going to hear as we go through this stuff. Moving into some arcs. If you look at these three circle pictures, we would say that arc TRS, and this is supposed to be an arc mark here, not so pointed, but I didn't have the right symbol. So arc TRS, that means we're starting at T, going through R and around to S. So technically there's a point there, you're just not seeing it. TRS is what we would call a semicircle. Okay, and a semicircle is going to be 180 degrees. So we would say the measure of arc TRS is 180, right? It's half a circle. A circle is always 360. This is half of that, so 180. Okay, next one, arc RS. We would say that is a minor arc. And a minor arc is always less than a semicircle. So we would say less than 180 degrees, essentially. Okay, that's a minor arc. And then RTS, that means we're starting at point R, going through T. That's not a very good line. Going through T over here and around to S. So what we're looking at is that arc. That's called a major arc. And a major arc is always named with 3 letters. Okay, a minor arc you can name with 2, or you could technically name it with 3 if you had another letter in there. But a major arc you have to name with 3 letters. That's how we know it's for sure a major arc, because you have to be able to go through something else. So that would be a major arc. Major arcs here, the way you could find the measure, we would do something like the measure of RTS. Okay, so the measure of that arc will equal 360 minus whatever arc RS was, right? Minus whatever this little piece of it was. What you're left over with then is going to be that arc itself. So you can always do the major arc minus the minor arc. Sorry, the full circle, 360, minus the minor arc. Okay, so if we're looking at example 1 here, sorry I didn't give you a lot of room for this, so we'll just blow it up a little bit. If this is our picture, and we are trying to find all of the minor arcs in this picture, those are all the ones that are less than 180 degrees. So arc AB, for instance, that would be a minor arc. Okay, now you could also say arc BA, but that's the same arc. You don't need to name it both ways. Another minor arc would be arc BE, so starting at B going to E. Arc ED or DE, either way. And then the last one would be arc AD. So those are all minor arcs. Then let's look at major arcs, and rather than list every single major arc, we're just going to do major arcs that have letter B as part of them. So if we look at major arcs containing B, I could do, for instance, A, B, D, right? Arc A, B, D would be that one. More than 180 degrees from arc through B going around to D. Or I could do, let's switch the color here, EBD. So starting at E, going around through B, all the way around to D. That'd be another major arc with B in it. I could do BEA, kind of out of colors here. Let's see. So BEA would go B through E all the way around to A. And then a fourth and final one would be BAE. Okay, so those would be major arcs that all have B as part of them. Note there are other ways that you could name that. So like arc ABD, you could also name as arc AED, and it's the exact same arc. Okay, so you don't need to name it a different way. And then the last one, the semicircles. When you name a semicircle, you have to make sure that you use 3 letters, because if I just say arc BD right now, for instance, let me get this stuff out of here. Okay, so let's say I'm looking at arc BD. Okay, well, I could be talking about this one, or I could be talking about the opposite side, that one. So you have to make sure you use a 3rd letter. So like for a semicircle here, arc BED would be one, and arc BAD would be a different one. So you need to make sure you name it both ways. And then same thing, if I start at ABE would be one, or ADE, would be another one. Notice EDA, if I am looking at this last one, if I just switch the order, EDA, that's the same arc. So again, you don't have to name it both ways, just one way is fine. Okay, so that's a lot about how you're naming them. Let's talk about their measure a little bit. Whatever your central angle is, so like here's my central angle, right? The angle opens up here to here, and that is 95 degrees. Your arc has the same measure. So we would say the measure of arc AB is 95 degrees. So an arc will always equal its central angle. So we can just write central angle equals its arc. Okay, and that brings us to the arc addition postulate. If I take the measure of arc AB, and I add to it the measure of arc BC. Angle addition postulate says that's going to equal the measure of arc AC, right? So the two pieces added together equal the whole thing. That's like segment addition postulate that we've done before. So AB plus BC equals that whole thing. Okay, segment addition postulate. This one is arc addition postulate, which you don't necessarily need the name of it, but I will write it here just in case you want it. Okay, the arc addition postulate. So what you're going to do with that is, given a problem like this, let's say, and I didn't write any of the numbers in there for you just because it's easier just to write them in as we do it. So here's what you're going to be given. Let's say you have a 60-degree angle here, a 20-degree angle here, and then my R didn't end up in the right spot. Sorry, R should be moved a little bit. So let's say this is my setup, and I want to know the measure of arc TR. Okay, arc TR means we're going from T through R. So I want to know how many degrees is that arc. Well, because my central angle is 60, then my arc is also 60. Okay, so how about the measure of arc TRS? That means I'm starting at T, going through R, and around to S. So what is the measure of that arc? And you'll notice this goes through the center of the circle, which means it's a diameter. And if it goes through a diameter like that, your arc then is a semicircle. So the arc itself would be 180 degrees. How about the measure of, let's switch this up, the measure of arc UTR. Okay, U to T to R, that's going to be this arc here. I already know this one's 60, and if this angle is 20, then this arc is 20. So really what you're doing for that one is just adding those two pieces together. So you get 80 degrees for the measure of that arc. Okay, and then last one of these, let's say we want the measure of arc RS. Okay, now think about what we've done with that. We said, let me get rid of some of these scribbles here. You know, I'm just going to redraw this real quick. So if this is 60, then this one was 60. If this is 20, then this one was 20. We want RS. We want this. Well, we know the whole thing is 180, right, with this diameter, and we know this is 60. So you're just going to go 180 minus 60, or 120 degrees. So that would be the measure of that arc then. Okay. All right, moving on. Circumference. Circumference is just another word for the perimeter of a circle, the distance around. And there are two formulas that you can use for circumference. The one that I typically use is this one, pi times diameter. Or, if you prefer, you may use 2 times pi times the radius. Think about if you double a radius, you get a diameter. So you may use either one. They are the same thing. I just usually always think of things in diameter type form. One thing to note, if you're leaving it in simplest radical, in terms of pi, if you're leaving something in terms of pi, you would leave the pi as pi. But if they ask you to round to the nearest tenth on something, you can use for pi 3.14, or technically 22/7 would be the same thing. Or you could just use your pi button on your calculator and plug it in that way also. That's fine. But just a couple options if you do have to round to, say, the nearest tenth or something. Okay, so with circles, we have here a picture of concentric circles. And concentric circles, it just means they have the same center. So this point is the center of the small circle and the center of the bigger circle. All circles are similar. If you think about radius compared to radius, it will be the same in any two circles. So all circles will always be similar to each other. If you look at this setup, let's say this small circle has a radius of h and the bigger circle has a radius of k. We would say this is a dilation, right? Because they are similar, they are proportional, but one grew or one shrunk, depending on which way we go. So if we're thinking of it as that this grew bigger, okay, we would say this is a dilation with a scale factor of k, the image, over h, the pre-image, okay? So that means we're going from smaller figure to bigger figure. Okay, so that's the relationship. You'll have a scale factor of the diameter of the new figure over the diameter of the old figure. So image over pre-image, right, is how we always said it. Okay, so just a couple examples with this stuff. Think NASCAR. If I am doing NASCAR, and, right, you always turn left, so here's the wheels of my car. If I'm driving around, which set of wheels actually travels farther? So this set of wheels goes this far, right? This set of wheels goes this far to do one lap. That outer set of wheels is actually traveling farther as the day goes. They only turn left, so it's always going to be that right set of wheels that goes further in the setup. So let's look at example 3 here. It says, how much farther do you travel on one loop of the bigger circle? So if I do one loop around on both circles, how much farther is it on the bigger circle? So you have to think about what that is that we're talking about. If we're asking distance, how much further, that's basically saying perimeter or circumference. So we would say the circumference of the smaller circle would be pi times diameter. The diameter of the smaller circle would be 14, right? If this is 7, then the diameter is going to be 14. So pi times 14 is the smaller diameter, or we like to write it with the number first and then the pi. So 14 pi feet would be one trip around the smaller circle. Okay, then the circumference of the larger circle, for that one, you're doing pi times diameter again, and our diameter on the large circle would be 20. So pi times 20, or 20 pi feet, is how far you would go around the larger circle. So think about what they asked. How much farther do you travel on one loop of the bigger circle? That's just difference, right? How much farther is it would be 20 pi minus 14 pi, or 6 pi feet. And last time I checked, it didn't make a whole lot of sense to say something was 6 pi feet long. So instead what we do is we just plug that in, 6 times 3.14, or hit your pi button. That's about 18.8 feet farther that you would travel on the bigger circle than you would on the smaller circle. Okay? Okay. Next thing we're going to talk about is arc measure versus arc length. Okay? When we talk measure, we're talking degrees. So some number of degrees. When we talk length, we're talking like feet or inches, some unit of measurement like that. So here's what I want you to see. In these two circles, they both have a central angle of 60. Well, a central angle is always equal to its arc. So if that's 60, then this arc is 60 and this arc is 60. So they're all 60 degrees, right? That's their measure, 60 degrees. Arc length is how long are they. So look at how long this arc is compared to how long that arc is. This second arc is definitely longer than the first one. So even though they have the same arc measure, it does not mean they have the same arc length. Or if they have the same arc length, it doesn't mean they necessarily have the same arc measure, okay? So just keep that in mind. Okay, so we're going to do something here with arc length. I gave you the formula here. This says the length of an arc is the measure of the arc over 360 times pi d. Or it might be written like this, the arc over 360 times pi d. That's fine also. Basically what you're doing is you're taking a fraction of the circumference, right? Pi d is circumference. We're just taking a fraction of it to figure out how long an arc is. So we're just going to use this formula on these two questions down below, and then you are done. So this first one says find the length of each arc. So arc RS, that's this arc. Okay, well if we think about how we plug that into this formula, it's the measure of the arc. So how many degrees is that arc? Well, I know the angle is 90, so the arc's got to be 90. Okay, so that would be 90 over 360, and then it's times the circumference, pi times the diameter. So this is your answer. It's just not in simplest form yet. What you do is you plug into your calculator everything but the pi. So 90 divided by 360 times 12. Okay? When you plug that in, you get 3, and then you attach your pi. So arc RS would be 3 pi centimeters long. Okay? Now look at the next one. Arc RTS, so this arc, R to T to S is this arc here. Notice we don't know how big that arc is, but we do know that this one is 100. So if that's making a complete circle, to find the measure of that arc, we're going to go 360 minus 100. So this arc is 260 degrees. Okay, now we're going to plug it into the formula. So it's the measure of the arc, right? Here's the formula up here. The measure of the arc, so 260 over 360 times pi times the diameter. And right now we just have a radius. If the radius is 9, then the diameter would be 18. So again, you're going to plug this into your calculator. 260 divided by 360 times 18, and you get 13 for that. And then you're going to attach your pi. So we're talking length. How long is this arc? It would be 13 pi, and we were talking feet. So that would be 13 pi feet. Okay, that is your lesson for the day. Get going on that homework, and I will see you tomorrow.